Dementia. Alzheimer's. It's hard to conjure up a specter that evokes more fear. These are slow and terrible death sentences. Victims have their minds erased, their dignity stolen. Their loved ones watch helplessly as those they care for are turned into hollow shells of their former selves. Billions of dollars have been poured into saving us from the horror of having our minds deleted line by line. But despite the intermittent optimism that follows the latest research findings, reality keeps crashing down on us that medicine has been powerless against the scourge of Alzheimer's. That is, until UCLA professor Dale Bredesen launched his innovative RECODE program. Bredesen has led the first recorded treatments leading to the reversal of Alzheimer's. His program is based off of 3 decades of groundbreaking research identifying the root causes of Alzheimer's. He argues that Alzheimer's is not simply the result of genetic predestination or sticky amyloid plaque buildup in the brain. It is actually the result of the body trying to protect the brain. To understand this, we have to know what Alzheimer's is. Let's zoom in so you can see how it plays out in the human body. Your brain is amazing. It has on average 100 billion neurons, and each of these has about 10,000 connections, which makes close to 1 quadrillion synapses. Synapses are what allow the brain to send signals that enable us to do everything from eating a delicious meal to sharing this video with all your friends. Now this is where it gets really fascinating. Neurons have receptors made of protein molecules which reach out and gather information, launching a sequence of biochemical reactions. There's a special subset of receptors called dependence receptors. They're extremely needy. These dependence receptors are dependent on a specific neurotrophic factor, which is a fancy way for saying something that stimulates cellular growth in the neuron. If the dependence receptor reaches out and can't find the neurotrophic support it needs, it initiates a suicide process, telling the neuron to die. If the receptor reaches out and finds its neurotrophic support, it sends the message that things are going just swimmingly and to proceed as normal. Cell suicide can also occur if dependence receptors are blocked from receiving neurotrophic support in the first place. That's exactly what the sticky plaque of Alzheimer's does. The peptide amyloid beta, and it can block your dependence receptors. Where does amyloid beta come from? Interestingly enough, it comes from a dependence receptor. Amyloid beta comes from a dependence receptor called amyloid precursor protein, or APP. Just a reminder, if a dependence receptor does not receive the support it needs, it tells the neuron to die. In the case of APP, which is a dependence receptor, if it does not catch the ligand netrin-1, which is the neurotrophin on which it depends, it tells the neuron to commit suicide. Then, APP is cut in 3 different places, creating 4 peptides, one of which is the dreaded amyloid beta. For the sake of simplicity, we are not going to talk about the other 3, but they also play a role in decreasing the brain synapses, shriveling neural connections, and activating the suicide program. So now there is more amyloid beta floating around. What happens if an APP receptor catches amyloid beta? Well, it blocks netrin-1 and tells APP to cut itself in the same 3 places, and, you guessed it, create more amyloid beta. So amyloid beta is like a tiny zombie biting APP and creating more of itself, and if this process continues, it has a cascading effect. It means there's more and more amyloid beta floating around, and it becomes much harder for the APP receptor to find its neurotrophic support. And no, that's not all. APP is no ordinary dependence receptor. It's a big boss receptor keeping tabs on whether other receptors are receiving enough trophic support, such as vitamin D or testosterone. And if they're not receiving enough support, what happens? 3 SNPs, same 4 bad peptides, including amyloid beta. And now we have some real problems. So at this point, things are looking really dismal, but there is hope. Sure, cell suicide sounds bad, but you have to keep in mind that it's serving a valuable function. APP can tell if there's enough trophic support to keep all the neurological functions going, and if there isn't, APP is trimming down the brain function so it can take care of the most vital tasks, like breathing and digesting. And here's the other good news. APP doesn't have to be cut in 4 pieces. It can be cut once, creating 2 peptides. These peptides signal to other neurons to keep up the good work because there's enough support for continued growth. This happens when APP captures its trophic support and also gets messages from other receptors that things are getting what they need. It signals that things in the brain are healthy and that it's safe to keep growing and connecting. As you probably figured out by now, in order to reverse Alzheimer's, we want to have APP cut in 2 pieces, not 4. What this does is shift the brain from being synaptoclastic, meaning that neurons are resorbed, to synaptoblastic, meaning neurons are produced and built up. And yes, there are things we can do. We need to get APP what it needs. Because APP is a big boss dependence receptor sending out messages based on many different factors, we need to work on a lot of different things, including diet, lifestyle, and toxicity exposure and detoxification. But again, this is really good news. There are things you can do to prevent and reverse Alzheimer's, which is what my next videos will explore. If this video piqued your interest, make sure to pick up Dale Bredesen's book, The End of Alzheimer's. You'll find some links below. Also, make sure to subscribe to my channel because I'm not done with this book, and my next video will explore the 3 main categories of attacks on your brain that induce Alzheimer's, and in my 3rd video, we'll explore Bredesen's Recode program recommendations. Also, if I may be so bold, watch some of my other videos here. Please like this video, comment below, and please, please, please share it with your loved ones. This information needs to get out there. If this video can help just one person, it's worth the countless hours it took me to put it together. And until next time, take good care of yourselves.